We definitely look at our lighting designs as sculpture. When we are designing things, we're not just thinking about how many lumens can this thing put out, but try to ask the question, what's this thing gonna make you feel like? I love its abilities to transform the way we experience a room. My name is Brendan Ravenhill. I'm the principal and founder of Brendan Ravenhill Studio. Brendan Ravenhill Studio is a design firm based in Los Angeles that specializes in lighting, furniture, and object design. I grew up with a father who was always spending time on the weekends building things, and so I really grew up with this familiarity with using my hands. I spent a couple of years as a boat builder, and I really got attracted to the idea of the complex forms and geometries that are involved. One of the very things that all objects need to respond to is gravity. It is physics, and so having an understanding of how those can be manipulated and controlled has really influenced a lot of the work that we do in our fixtures. Our design philosophy really believes that objects should be devoid of ornament and excess. And so our pivot family, we decided to expose the wire and rather than hiding it, make it part of the structure. So a cloth-covered wire not only provides power, but actually helps hold it aloft. When we created the pivot family, it was really to try to create a shade that created a nice directional downlight, but that could also be able to pivot the lamp up or down or to the side. When we first started designing, there was a lot of hand drawing, a lot of sketching to kind of create the components. And after a bunch of hand drawing, we took it to the shop where we made some prototypes. Once we were able to model and prototype, we take that model and put it into a CAD program, which allows us to really dial in the tolerances and the little details of the fixture and making sure that all the corresponding tech fits in it. And from that model, we're able to create a set of build drawings, which we send to our vendors for the first prototypes. The first thing they did was to build a mold that matched our tolerances and our specs. And it was that mold that they end up chucking in the lathe and use in the metal spinning process. That piece of aluminum starts out as a square piece that's taken onto the circle cutter, put in and cut into a disc. That disc is then taken to a metal spinning lathe where it is clamped against the mold to create the bowl shape that becomes our pivot shade. After the shade is spun, we take it over to a hydraulic press where we're able to orient it in just the right way so that when we punch a hole, it's exactly in the right location to hold the metal cone which houses our electrical sockets. And then the two of those are oriented in a careful jig and held in place while three little TIG welds are put on to kind of join the two pieces together. Once that cone and shade have been welded together, that becomes our final assembly, which we send out to be painted. We start creating our wiring assembly by carefully cutting and measuring all our pieces of wire and joining them together with crimp caps into a wiring harness. Then we take that whole assembly and we thread it through our wiring hub. The next step is to create the arms that will actually support the fixture and compression. We do that by taking 1/4-inch metal rods and inserting them with a little bit of glue into these machined brass collars. Those we let set up and dry, and then we take them over to our arm cutter or rod cutter, cut all the rods to length. Then we carefully deburr the ends of the rods on a disc sander, and then they're ready for assembly. We take the cloth-covered wires that come out of the hub and insert them into the freshly painted pivot shades, where we therefore make the connection to the electrical socket. With all 6 shades wired and connected to the sockets, we therefore take the next step of assembling the fixture one by one, inserting our metal arms into the center brass hub. Similar to how a kite works, at first it has no shape, and as you start adding each individual rod into the brass hub, it starts to resist in compression the tension force of the wires. And when the last one kind of comes together and clicks in place, the whole structure suddenly becomes this carefully balanced system that kind of floats in space. Seeing a pivot chandelier finally come together is a pretty satisfying feeling because you see how careful attention to detail and process creates this very lightweight armature that kind of defies physics in a sense. We're able to create these assemblies that, when all the pieces come together, end up having this poetic moment of everything kind of responding and reacting to each other.